So I haven't said yet how we're going to actually estimate beta 0 and beta 1. It turns out that the way we come up with estimates of beta 0 and beta 1 is to minimize this quantity, to minimize the sum of the squared residuals. How would we do that? Well, first notice that minimizing the sum of the squared residuals divided by n minus 2 is the same as minimizing the sum of the squared residuals, right? I don't need this right here. So that's fine. So how am I going to do this? First, let's just talk about this intuitively. My arm is the regression line. For every possible regression line, we could think about how far a point is from the line, and we could think about how big the square of that difference is. Here's another point. Here's how far this point is from the line. Here's the square of that one, right? Here's how far this point is from the line, and a square. For every line that I could think of, there's a bunch of possible squares. Let me draw another one. Suppose I choose a line like this, and I want to know the sum of the squared residuals. Well, now they're all going to be really big, right? This one, the residual's that big, and this one, the residual's that big, right? And this one, the residual's that big when I square it. So I want to choose the line that minimizes the sums of those squares. And that's going to be a line that goes as close as possible to the middle of those points, typically. So conceptually, that's what we're trying to do. Minimize the sum of the squared residuals. Minimize the amount by which the points vary from the line as measured by the sum of the squared residuals. Again, you could just as easily justify minimizing the median of the absolute value of the residuals. That's fine, but this is the convention. This is what a regression is. Okay, so mathematically, how do we do it? I can talk about waving my arm around and it's a regression line and we see some squares. But mathematically, how do we do this? Well, if you've had a calculus class, you know that we can take the derivative of this expression right here, set it equal to 0, and solve. So we can take the derivative with respect to beta 0, set that equal to 0, take the derivative with respect to beta 1, set that equal to 0. And if we solve those equations for beta 0 and beta 1, turns out we get our answer. If you haven't had calculus, it is possible to use calculus to find the two values that minimize this total sum. Let me write this sum a different way so you can see how we might do that if we were going to do it with calculus. So for each of these data points, I'm now going to call it just yi, where I is an index. I is a number between 1 and n. Okay, the residual is yi minus beta 0 plus beta 1 times xi. Right? Whole thing squared. And then I sum them up. So there's my big summation sign. Okay? This is the quantity that we're trying to minimize. This is easier than writing out this whole expression, right? This is the quantity that we're trying to minimize. And so again, if you've had calculus, you can see we can take the derivative of this quantity with respect to each of these two parameters and solve to minimize those two parameters. If I did use calculus to minimize the sum of the squared residuals, here's what I would get. For beta 1, I get the following quantity. Take the sum of the differences between each y value and the mean of all the y's times the difference between each x value and the mean of all the x's divided by the sum of all the x values minus the mean of the x's squared. We're going to talk about this expression in a few different ways, but that's what the expression is. Okay, and if we wanted to then get an estimate for beta 0, what we do is we plug it in. So we have our regression equation. The mean of y is equal to beta 0 plus beta 1 x. If you plug in that estimate of beta 1, and then you plug in here y bar, and you plug in here x bar, and you solve, that's what beta 0 is. So beta 1 comes from minimizing the sum of squared residuals. And you could do the same thing for beta 0, but what you'd get is a value that comes from saying, okay, what's the mean of x and what's the mean of y, and making sure your line goes through that point. The regression line will always go through x bar comma y bar. So if I solve here, this is equal to y bar minus beta 1 x bar. We're going to focus on this expression because, again, this one, the equation for the intercept estimate, just comes from making sure that the line goes through the middle point.